Hey, and welcome on LabHub back. So today we're gonna talk about a really important thing if you want to be an astrophysicist or maybe aerospace engineer. So this is the gravitation. And important notice for now, this is Newtonian gravity. So in the future, there will be a guy, an Albert Einstein, who will change the whole interpretation of the gravity. But this one, what we're talking about now, it works with school, it works with college, and it works in a real world. Einstein's gravity, it's for more fundamental things. So just don't be afraid of this knowledge. Will be not so useful when you meet the Einstein's gravity. This one, the Newtonian gravity, will be something that you don't need to use at all. No, it's completely not like this. So we'll start with the constants. At first, we got a constant called escape velocity. And escape velocity is always equal to 11.2 kilometers per second. This is the escape velocity for the Earth. And for each planet, this velocity can be calculated differently. And here's the formula for it. It's equal to root 2 big G mass of the planet divided by its radius. And it's all clear here, except this thing. What is big G? Big G is a gravitational constant, right? So it approximately equals to 6.6743 times 10 in the negative 11 power. This is just a constant we use everywhere. While small g, that equal 9.8, we use only for the Earth, right? Earth. We use the universe-wide. I don't want to say a worldwide because it's not for only the Earth, like we usually tell it. So this is for everywhere, right? Everywhere. While this is for only the Earth. And now some boring theory. Kepler's law. Kepler's law of a planetary motion describes how planets orbit the sun in three main ways. First law says that planets move in elliptical orbits with the sun at one focus. What does it mean? We got a sun, right? We got a sun, and the orbit isn't a perfect circle, right? It's not perfect, but let's imagine that this one is perfect. The orbit looks like this, right? Or even like this, or even like this one, right? So it's not perfectly circle. It's not perfectly circular. It's more eclipse. So the second law, a line from the sun to a planet sweeps out equal areas in equal amounts of time. And the third law, the square of a planet's orbital period is proportional to the cube of the semi-major axis of its orbit. It's too complicated for a school level and for an intermediate level, right? So this is just what you need to memorize and to answer to a teacher in the school, but we won't really use it. This is the laws we need to understand and we need to know, not to write like this. We need to be able to visualize the only first law. The second and third is not so useful. And the last thing, is Newtonian gravitation. This is the law of the universal gravitation. And this is a force. On the advanced level, you will realize why it's not a force. But for now, as I said at the beginning of the lesson, this is a force, we follow it, and it works in a real world, right? So don't be so strict with the terms, right? So the gravitational force according to the gravitational force according to Sir Isaac Newton equal to the gravitational constant times m1, m2 divided by radius. What does it mean? This is the constant, we already know it. This is body 1, this is body 2, and this is the radius between them. So we got planet 1, we got planet 2, we got a radius between them in 100 kilometers, m1, m2. So it states that two bodies attract each other. They attract each other no matter which body is it. And it depends on their mass and on the radius between them. This is the basics of theory of the relativity by Einstein, and this is only the concept of it. But in a Newtonian gravity, this is exactly how it works. We got two massive bodies, right? And they attract each other, just like our planet, just like our sun, does not give us a chance to escape the solar system. And times gravitational constant, we use it in many formulas on the gravity and the space at all. And one interesting example before we end. If you will see it right in front of me, we still attract each other because we got some radius between us and we got our masses. But since our masses are not as great as planets, we can't attract each other like the planets do. So that's all you need to know about the gravity on the intermediate level right now, on a school level. Good luck.